Hello, everyone. My name is Hardy, and I'm an intern at Side Effects. Today, we'll be talking about fun with Renderman and Solaris. So, what this is basically a short summary of my experience rendering with Renderman within Solaris during my first project as an intern in Side Effects. So, before we get into it, let me show you what the final result looks like. So this is the project basically. A lighthouse being destroyed by a giant wave, and it turns out it's in a snow globe in a windowsill. Right, so that's what the project looks like. Now back to the presentation. So I'll break it down step by step as to what I did to complete the project. This is an overview of that. First, I assembled the assets and then import the assets into the main Houdini file. And over there, I brought in some other assets that were already prepared. They were actually some of the Magic Market assets that were already done by Side Effects. And then I just laid them out there within a scene. And then after it's laid out, I took just the snow globe and the lighthouse and brought them into the OBJ context where I made the effects. So I fractured the lighthouse in OBJ. I made the glass and the rocks and all that as colliders. And then once the effects are all done, they're brought back into Solaris. And then after that, I made some materials for the objects, for all the assets, and assigned them, lit them all in Solaris, animated the camera, and did all the render settings stuff over there in Solaris. And this is all done in Solaris with Renderman. So Renderman materials and Renderman render settings. Cool. So asset assembly. There's two assets that I made, essentially, two USD assets. So the first one is the rock asset USD. These rocks were modeled procedurally based on one of the tutorials that Side Effects put out about procedural rock modeling. It's really good. Please check it out. I learned that from there. So all the textures and all that, that's also procedural, so it's nice. And by just tweaking some of the noise parameters, I could get 3 different variants of the rocks, which I then put into one USD file. And the idea is to bring those 3 different kinds of rocks into the main Houdini file, where I will scatter them, as you can see in the third picture. The second asset that I made is the snow globe asset itself, the hero asset. So it's modeled in Houdini, modeled procedurally, and then it's all packaged up into one USD file. So the lighthouse, all its glass and parts, they're all modeled in Houdini, and the base of the snow globe, the glass of the snow globe, they're all modeled in Houdini in a separate Houdini file, and then I brought them all into the stage context. So it's all one snow globe ready to be brought into the main Houdini file. And within the main Houdini file, as I mentioned before, I brought in the rocks as well and instanced them on the seafloor geometry, which is that dome looking thing at the bottom of the lighthouse. And the nice thing about the instancer lop, which is what I use to instance these rocks onto the seafloor geometry, is that the instancer lops works pretty much like copy to points work in SOPs. Like all the attributes are pretty much the same. So like p scale, the normal attribute for the points and all stuff like that to control the size and orientation of each instance works pretty much like the copy to points SOP. So it's really nice. So this is what the Lighthouse asset setup looks like. So as I mentioned before, it's set up, it's modeled in a different Houdini file than the main Houdini file where I did the rendering. So yeah, this I modeled it in OBJ. So if we take a look at OBJ context, this is the model. There's a lighthouse inside there and all the other stuff, the base, the seafloor, the glass, the base. And I just brought it into Solaris, brought it to Lops using a SOP import. So if we take a look at that, just brought it in, import it one by one. And that's it. Don't forget to set the primitive path and the layer safe path. And translate the lighthouse up a bit. I had to do that because as I imported it, I imported everything in. The lighthouse was actually sitting at Y0, so it's actually sitting on the ground, technically. So it's intersecting with the base. And so I wanted to lift it up, but I didn't want to just lift it up using a transform. I mean, maybe you can, but I couldn't figure out how to make it procedural in a way because I can't use bbox, the bbox H strip. So I had to use a wrangle and do it that way. There might be an easier way to do this, but this is what I did. Basically brought in the maximum bounding box of the base, made a translate y vector, how much I want to translate up, and use this USD add translate function and lifted it up based on how high this base is. Right, so the nice thing about that is if the base has to change its height and all that, it's procedural, right? So this lighthouse will always be sitting on top of the base, even if the base changes height. And then another thing that I had to figure out is this glass, this lighthouse glass is white and we can't see through it. We can, even with the wireframe view, it's kind of hard to see, which is not ideal. So I made this material library and made a USD preview surface material within it. And I just set the opacity from 1 to 0. And well, technically you can use this USD preview surface for render, but I don't think it's as nice or as flexible as what the Karma or the Renderman materials would be. So this is not really for rendering, it's just for preview purposes, for ease of use purposes. And well, this is the material I made before, and then this is the primitive I want to apply the material to. If we take a look at that, now we can see through it. And that's it. And just add a USD rock to write all the USDs out. So this is what the rock asset setup looks like. The rock procedural modeling is based on a tutorial that Moeen made and side effects uploaded on their YouTube channel. And this is pretty much almost a one-to-one recreation of what Moeen did. And this is basically cleaning up the rocks that the tool generated and cleaning it up and making it ready for Solaris. So if we go back to the stage, first we make the materials, and the materials are Renderman materials because we want to use Renderman. And these textures has to be TX. So I had to convert the textures that the tool generated into TX just using the Renderman texture manager. You can convert, I believe, pretty much almost any image file format, and convert it into TX, which can then be read by the Renderman renderer. And this one I actually plugged in a principled shader, which works with Karma, and a Renderman shader, which works with Renderman, so that I can use this rock assets that I made in other projects too, potentially. And when you're rendering, it's able to figure out if it should use one or the other. And then this is importing the rocks into Solaris and referencing the materials into each branch, and assigning the materials for each branch, and now creating the variant. So as you can see, right now the one we're viewing is rock 3, this guy, and we can switch between variants using a set variant. So instead of rock 3, I want the default to be rock 1, let's say. So I can just set that into rock 1, and then you can just export that. So now layout assets, we already have the rocks, and we already have the lighthouses, the snow globe, all set up. Now we just want to lay them all out in the scene. So I also grabbed some pots and plants and a book from the Magic Market scene that Side Effects already made previously, and it's also available to check out, download, and play around with for free. And what I did is I just basically grabbed some of those assets and brought them into my scene. And the nice thing about it is that it's already AUSD, it's already nicely packaged and all that with the materials. But the issue I had was it was prepared for Karma render, not for Renderman, which meant that I should rebuild it with Renderman materials. But fortunately, I didn't have to necessarily do that, because when you make a asset with a principled shader, they also make a USD preview shader under the hood, which is what we actually see in the viewport. Just like what we did with the glass earlier, I assigned a USD preview shader. So when you make a principled shader, it actually just does that under the hood. And you can actually use that USD preview shader to render, which is what I actually did in the end. Like all these pots and plants, they're all just using the USD preview shader. And though it might not be ideal, it looks pretty much almost the same, I would say. So I actually did a test, like the book. I rebuilt that with Renderman materials, but the pots and plants, I just had them as USD preview shader, and they both look pretty much the same, I'd say. And so that's a fortunate thing that happened. Maybe it's also due to the materials being fairly simple. I think the USD preview shader in this case works just fine. And now we want to import everything into the scene. So we have this, we're just referencing some USD assets that's already prepared, the clay jars. So if we take a look at those, they're really tiny because it's modeled in realistic dimensions, and the lighthouse is modeled in realistic dimensions, so it's actually life-size sort of, which means the snow globe is super huge. But yeah, this is the clay jar, and just setting it to a variant that I like, and importing some more clay jars, plants, and stuff, and setting it to the variant that I prefer, and also the book. I also imported a room that I modeled just outside in OBJ, and just imported into this into the scene, into LOPS, and I'm just transforming them, translating them, and scaling them up, maybe rotating them somewhat with these transforms over here. So if we take a look at the whole scene, this is the giant room, that's the snow globe right there, and I'll just be transforming them somewhere over there on the windowsill. So if we take a look at that, just transforming them up there, the book over there, and all the clay jars and the herbs. And I'm not doing anything fancy here, it's just dragging these handles, these controllers, to where I want them to be. And as you can see, for the clay jars and the plants and the book, they're scaled up to a pretty high number because everything else is huge in this scene. I also imported, I actually created a ceiling plane, which is just a grid on the top of the room, just so that light does not come in from the ceiling, it comes in from outside the window, because the room is not supposed to be ceiling less. And I also made sure that it's not visible in camera. And I also added some dust particles around the snow globe area, so that it just adds more atmosphere to the scene. So for the effects, as I mentioned before, it's actually done in OBJ context. So I had to bring the lighthouse asset and the snow globe into OBJ context just using a lop import SOP. And I had to unpack the pack USDs into geometry so that we can fracture that, make that into collision, and all that FX processes that goes on in there. After that, I had to bring the finished effects back into Solaris. So I'm just going to briefly go into how the effects were made. So as I said before, I'm just bringing the lighthouse asset into SOPs and doing fracturing collisions over there, making the narrowband flip tank, and the flip fluids and the RBDs are actually interacting in the same simulation, in the same DOP. And the surface volume was used to break the RBD constraints based on the surface attribute at the point of the RBD piece. And if it reaches a certain threshold, it'll break and it'll start getting pushed around by the velocity volume. But I'm only transferring a portion of the velocity volume, velocity attribute onto the RBD point, so that it'll collide first before it starts getting pushed by the velocity attribute. This might not be the most accurate representation of this effect, maybe because it feels like it's a workaround of sorts, but I feel like it is good enough to sell the effect that this lighthouse is being broken by the wave and being pushed around by the wave. And once the effects are all done, all that post-processing and stuff like that, I get it back into Solaris using a SOP import lop. We've used that before, right? And I also had to use a prune because there are actually, once I bring the effects back into Solaris, there are actually two lighthouses. One that is the one we use for layout and all that, and the new one, which is already fractured and simulated and stuff like that. So I wanted to hide the old one or deactivate it because you can't really delete or remove primitive that's already within the within LOPS, within Solaris. You can't actually delete it. So the way to do things is you hide it or deactivate it, which is why I use this prune. And I hid the previous lighthouse before the simulation and the effects and all that. So if we take a look at the OBJ context, so if we go up to OBJ, so I imported the lighthouse assets into here. This is where all the fracturing stuff happens. So like I said, I just imported the lighthouse asset, in this case just the lighthouse, because I just want to fracture the lighthouse using this lop import. So I'm just referencing the lop path which is in stage, and this lighthouse layout, which is a null that was up here before, way up here. And so this is actually the lighthouse before all this transforming, moving it up within the room environment. So it's still actually in the center of the world. And when I import that, and I'm also just importing this lighthouse primitive specifically because I just want to fracture this one lighthouse. And if we take a look, it's a packed USD. So if we want to work on it, I had to change it to, I had to unpack it and make it into polygons. And yeah, this is basically all the fracturing process. Yeah. And same thing with the base, the sea floor, and the rocks is just being unpacked into geometry, combined, and made into some convex collisions for the RBDs and some volume collisions for the flip. And this is where the prepping for the creation of the narrowband stuff. I'm just importing object merge the glass and also the collisions, which goes through here and makes this. And all this will go into the DOP network. And the stuff I mentioned earlier with the interaction, that's pretty much done in SOP solver that's plugged into the RBD solver. So let's just stop that for a bit. And if we manual this, take a look at this guy. This is where the constraint breaking happens. So it's reading in the surface attribute and break by surface attribute. So if the surface attribute at the point of that constraint is less than 1.3, it'll break and it'll start getting pushed by the velocity volumes, which happens over here. Right, so if the surface attribute is less than 1.3, it'll start getting some velocity and start getting pushed around. And so there's quite a few effects over here. So there's the RBDs. This is the null that represents the final RBD simulation. Right, so that's that. And here is the dust. That's part of the RBD simulation. This is the flip stuff. So all these effects all point out to a null at the end. And I just use that as a reference point for when I import it into Solaris. So once all the effects are done within OBJ context, I bring it into Solaris using all these imports. As you can see, they point back to that null that I have at the end of every effect. So if we take a look at that. Oh, and a nice thing is, since this is being put in the primitive path within the snow globe primitive, the transform also applies onto these effects. So even though the effects were done in the center of the world, it'll still get transformed to wherever the snow globe is, because the snow globe has that transform. So if we take a look at the snow globe again, as you can see, the lighthouse is not at the center of the world, but over here within the snow globe. As I mentioned before, I had to hide the old lighthouse too. So if I don't have that prune, we'll just see two lighthouses, which would just be awkward. So I had to hide one of them and also import the rest of the flip and all the other effects. So now on to material create and assign. So I created some materials within the material library lop. So I made a material library lop, and within that is where you would create materials. And it works pretty much like the material context in the more traditional workflow of Houdini, where you would create some principled shaders and all that. And it works pretty much the same over here, which is nice. And also textures, I had to texture the lighthouse and parts of the snow globe in Substance Painter. I then export that as a PNG file, which then I had to convert to .tx because that's the file format that Renderman wants to work with. And also, I mentioned this before, but I used the collect VOP so that I can use two materials at the same time, in a sense. And also for the material assigning, I use the material assign material node. I actually could have done that with the material library lop, but I didn't because I didn't know that before. So I did that. But then material assign is actually pretty interesting because it allows you to write vex expressions. And like one of the uses I had for a different project is that I can type up some vex and read a primvar attribute from, let's say, if I also have a shop underscore material path attribute from SOPs, if you do a SOP import, it'll automatically also make that into a primvar, and you can use that attribute to potentially assign some materials with the same name in the material library lop, which is really cool. So you don't have to like assign things manually if you have like 100 or 1,000 different objects that you have already prepped in OBJ context. So this is the scene, and if we see, I made a material library lop, which is where I create all these materials. It looks pretty much like a material context. And as you can see, I have a collect VOP for every shader that I have. I'm not necessarily using it to plug in multiple shaders, but I just use most of them just for organization purposes. And if I wanted to add another material, it wouldn't be a hassle to reassign things to a different named VOP or something like that. And I actually did use some of these collect VOPs for multiple materials like this one. So this window glass material, There's a Pixar surface shader and also a principled shader that's plugged into this collect VOP. The reason why is I wanted to see through this glass panel behind the scene. And the nice thing about the principled shader, as I mentioned before, it also creates a USD preview shader underneath. So even though it's a principled shader, there's also a USD preview shader. When I change this transparency from 0 to 1, it actually shows in the viewport, in the Houdini GL viewport later on. So if we go out and look at the assigned materials, it's just the primitive you want to apply the material to and what material you want to apply. And if we just look at all these assigns, as we can see, the window is now see-through. We can see beyond, even though there's nothing over there, but it makes more sense to me. And also, we see that now the whole room is blue, and we can see that these other things have solid colors now. And the reason why is I am using a Pixar Disney shader. These Pixar Disney shaders, they have a base color, and these are basically the base colors, even though I'm plugging in a texture, but the preview that we're seeing is the base color that was applied on there. So if we take a look at an example of this, let's say the windowsill material, so this block right here where everything sits on. If we take a look at the Disney shader, the base color is blue, even though we're plugging in a Pixar texture node over here. It's still just showing us this base color. So we can actually change that. So like this snow globe base and the lighthouse, they're also using a Pixar Disney shader with a texture attached to it. But then I purposefully changed the base color so that I can distinguish, and so that not everything is blue. If I disconnect this and change this color to like yellow, for example, you can see it'll change to yellow even though I plugged the texture back in. This is just for preview purposes. When you render actually with Renderman, you'll see that this actually uses the texture that I plugged in. And now we move on to lighting. For this lighting setup, it's pretty standard. Like I didn't do any fancy lighting tricks, and unfortunately I didn't also use the cool new light placement things that Solaris is known for. I just put in some lights, made some lights, and manually moved them around using the transform handles, the transform controls, and it seemed pretty fine for me, for my purposes, because I didn't use too many lights. And I also used a light mixer so that I can tune the lights in one node. But I think it did not make my work that much easier because I didn't have that many lights. I find it that it didn't bother me to just jump between the light nodes and change them there. But definitely if you're working with more than 10 lights, it would probably be better if you use a light mixer, and especially if it can be controlled. If you make like a group of lights into a collection and you can also control it that way, that would be a really neat thing to do. I also used a light linker at the end of everything. I wanted to add a rim light just for the lighthouse so that it looks nicer, but then I didn't want that rim light to affect anything else because everything else looked fine, except I think the lighthouse would look a lot better if there was some rim light. So I just made a rule where this rim light does not affect anything else except this lighthouse. If you're familiar with how it works in Maya, it could be object-centric and also light-centric. You just have to drag either the lights or the objects into the rule area. So here's the scene, and these are all the lights that I have, all these 7 lights. There's this light mixer, and this is where you can control things. I didn't really do much with it, but I did something. And as I said before, it didn't really help me much because I didn't find it too hard to just jump around on to these nodes and just change it over there rather than changing it in the light mixer. But if you have a bunch more lights, I think it would be wise to use a light mixer because it's just uh, a hassle to go around through like 20 or 30 lights. And I also have this light linker. Um, this is where I mentioned, like, I have this lighthouse rim light, and this is the rule. It only affects this guy, lighthouse rigid sim, which is the lighthouse RBD simulation, and nothing else. So that's how I use that. So render and camera. For the camera, I actually just made a camera and keyframe animated the camera within Solaris. And it works pretty much the same as how you would keyframe animate a camera in OBJ context. And for render, I'll get into it a bit more when we look at the HIP file, but I rendered it in 3 different passes. So the environment, just the lighthouse, and just the floaty dust particles. And with the nuke, I just kind of just merged it together, and it looks like this, the final result. Yeah, so let's see the HIP file. So these are the render settings and the camera stuff that I did for this project. As you can see, there's a bunch of render geometry settings, and what these nodes do is they just change the render settings for each of the geometry that you want to change. Like for this one, for example, like I wanted to see through all these layers of glass, and to do that, you have to change the max specular depth, or else you'll just see black on the glass because you're not letting the camera rays go through that many layers of glass. So I had to increase that to a higher number. I think the default is 2, and that just won't cut it. So I increased it to 8, and I was able to see through all the layers of glass. And another thing I did was I just changed the intersect priority, messed with some of the auto trace bias settings, and also I turned on displacement for the rocks, because without this on, I don't think it renders with displacement by default. And here's the camera that I animated. So I animated the position, and since this camera is moving away, I also animated the focus distance. And these numbers look a bit weird because everything is super huge and not actually accurate in terms of scale. So I had to compensate it with some weird numbers, but it seemed to work okay. This f-stop, I believe, like to have that miniature look with a very shallow depth of field, I had to lower the f-stop to ridiculously low numbers, so which is why it looks like that. And also, since in the beginning of the shot, I want everything to be more in focus, as you would normally see when looking at a normal lighthouse. But then as the camera pulls out, it reveals that it's a snow globe. So I had to lower the f-stop quite a bit so that it looks like it reveals that, like, oh, this snow globe is actually a miniature instead of like a life-size lighthouse. And so as I might have mentioned before, I have 3 different renders. So there's one that's just the snow globe, another that's just the environment, and another that's just the dust particles. So for this one, I added its own render geometry settings. So this one specifically, I made all of these primitives, like the books, the clay jars, the room, and the herbs. I made them all into a matte, so it doesn't have any alpha or color in the beauty pass. And then I also turned off the dust particles visibility, so it won't render in the final result. So the result of this guy will just be the snow globe and the lighthouse and all the effects inside that. And for this branch, this is just the environment. And as you can see, I turned all the snow globe stuff, all the primitives under scene/snow globe will become a matte. And same thing, I turned off the visibility for the dust particles so it won't render. And for the last branch, I made everything that is not the dust particles a matte, and I turned off the visibility of the snow globe and also the environment. And this little wrangle right here, what it basically does, it makes the camera's f-stop value to 0. And the reason why I did that is I didn't want this dust particle render to have any depth of field blur right out of Renderman, because I want to apply the depth of field blur in Nuke, just because I think that is the cheaper way to go in terms of render times. And it also will probably look cleaner, less noise. So that's what I did. And yeah, so in the end, in Nuke, I just had to merge all these together pretty much. And that's the final result. So that's it for the whole project, pretty much. And now I'll talk briefly about some issues that I faced during the whole process. So number one is motion blur. I couldn't figure out how to do motion blur in Renderman. There might be some secret switch somewhere, but I'm not sure where I should find that. I know that Renderman does motion blur in Solaris. I've seen like a few presentations where that was demonstrated, but I personally couldn't find it. I also did a test with the same geometry and the same velocity attributes and all that, and it worked fine in Karma. But when I switched it over to Renderman, there wasn't any motion blur. I tried changing the velocity attributes, multiplying it by 2, multiplying it by 100, nothing changed. So I'm not sure how to get motion blur to work just yet, but I know it's able to do that. Number 2 is denoising. I know that in Renderman's documentation of Solaris, it explicitly says that interactive denoising is not supported just yet, which is why I didn't use any denoising. I just pushed the noise really low by increasing render times and all that, increasing sample count, which actually is why it took a really long time to render. For me, I rendered in my personal computer. It took about a month or so to render the whole project. So it actually took a while to render, and unfortunate that I couldn't figure out how denoising would work. There might be denoising by other means rather than the interactive denoising that Renderman in the traditional way to render in Houdini usually does, but I couldn't figure it out just yet. But yeah, so I didn't do denoising. And number 3 is unfortunately there's not enough documentation yet from Renderman about Solaris and how to render in Solaris. So it's not the easiest to navigate around. But I'm sure as time goes on, Renderman would update their documentation, and they have been doing an awesome job in the past, and I'm sure it'll be the same with this new Solaris documentation. And that's it. Thank you for having me in this LA Hug. Hope someone learned something. And yeah, all right, see ya.